Good day, students. Today we are going to continue under Newton's law of motion, and we have looked at the motion of a body that is on an inclined plane, and I think we took an example last week, and today we are going to talk about motion of connected particles. Okay, all right. So when we talk about connected particles here, we are talking about two or more bodies connected by a light. All right, two or more bodies, all right, connected by a light inextensible string. Okay, all right, connected to a light smooth, all right, pulley. So when we say motion of connected particles, we are dealing with two or more bodies connected by a light inextensible string connected to a light smooth pulley. All right, and the assumption we are making here is that the force in the string, which we call the tension anyway, is constant, all right, throughout every section. All right, so if we have two or more bodies that are connected, all right, probably with a pulley, two or more bodies that are connected, as many as possible, by the same rope, all right, maybe over a pulley, we are assuming that it is the same force that is acting on the tension all through on the string, all through the parts, all right, of the string. The same force is at work. All right, so let me show you an example that we are going to consider. An example. Now look at example 7. It says two particles whose masses are 15 kilogram and 12 kilogram respectively are attached to the ends of a light inextensible string. All right, the string passes over a light frictionless pulley and the mass hang freely. The system is released from rest when the 15 kilogram meter is 32 meter above the floor. All right, now the question is find the tension in the string, all right, and the time taken by the 15 kilogram mass to reach the floor. Okay, so look at that. All right, you can pause the video and try to take down the question. Okay, so we have a solution like this. All right, we have this. We have two masses. Okay, 15 kilogram is 15 kg. All right, and we have another. This is 12. Okay, this is 12 kg. This first one. Okay, and because 15 kg is here, the rope will move in this direction. It will move in the downward direction. So please take note of this. The tension here is downward. Okay, the tension here too is downward, but you see, pay attention to this. Now while the tension here is pulling it down, all right, now one time or the other, that tension will be greater than what this body offers, and it will pull it up too. But let's just pay attention. So the same tension here is same tension here. Please pay attention to that. The same tension here, all right, is the same tension here. So the tension here is moving up, the tension here is moving down. Did you get what I just said? The force on this rope is upward here, the force on this rope is downward here. Okay, so now pay attention to that. So remember that on this 15 kg there is a weight. Weight is mg. All right, the weight here is 15 times g, which is 15g. Remember, g is 10 or 9.8 meter per second square, depending on what we are given. All right, there is also a weight here, all right, which is mg, which is 12 times g, which is 12g. All right, so in this case, if we say 15g, g is 10, that'll be 15 times 10, which is 150 newton. So the weight here is 150 newton, all right, while the weight here is 120 newton. Remember that weight will act down. Do you get what I'm saying? The weight will act down. Pay attention to that. The weight will act down. Okay, now please pay attention to this, that we are going to take each body one by one. We are going to analyze the forces on the 15 kilogram, and we are going to analyze the force on the 12 kilogram mass. So let's take it one by one. Let's start with the 15 kilogram mass. All right, the weight is 150 Newton. All right, there is a tension on it. Now, if you are familiar with, a body that is being hung on a rope, you will realize that if the weight is going down, the tension is going up. The tension will act opposite to the weight. I get what I'm trying. The tension will act opposite to the weight. Now, the reason why the body will move down is if the weight is stronger than the tension. Do you get what I'm saying? All right. The reason why the body will move down is if the weight is stronger than the tension. But if the tension is stronger than the weight, the body will be moving up instead. For example, if I hold an heavy object, please pay attention. If I hold an heavy object with a rope, all right, if the object is quite heavy, all right, it is the object that will pull down the weight. All right, but if I'm holding the object up and the force I'm applying on that rope is small, I can pull it up easily. All right, but in this case, the question says the system is released from rest when the 15 kilogram mass is 32 meters above the floor. So that means the body began to move. The body began to move. That's why the body began to move down. All right, so now remember I said something last class. I said net force equals to mass times acceleration. All right, net force is mass times acceleration. So in this case, tension acting up, all right, weight acting down, what will be the net force? It will be 150 minus tension. Why did I use 150 minus tension? Because the body was moving down. Assuming the body was moving up, it will be tension, all right, it will be tension minus 150. Do you get what that? So equals to MA. What's our M? Our M is 15, mass 15A. All right, let's keep this. Let's call it equation 1. Now let's take the other body, which is 12 kilogram body. All right, this is 120 Newton and this is tension. All right, remember that. Now let me bring the diagram back. The body is moving like this. So that means that if the body is moving like this 120 Newton is moving like this. All right, so it tells you that in this case, all right, in the case of the 120 12 kilogram body, it is moving up. All right, it is moving up. So that means that this tension is greater than the 120. So how do we write the net force? Remember, it's still net force equals to MA. So our net force is T minus weight, which is 120, equals to 12 times A. Are you getting what I'm saying? Okay, so we have T minus 120 equals to, all right, 12A. Okay, now here, this equation 2, we can make this out of formula. We can say T equals to 12A plus 120. Okay, now this is like a simultaneous equation. All right, so we can substitute this now. All right, we can substitute this now into our equation 1. T is 12A plus 120. Okay, we can substitute it into equation 1. All right, so we have something like this. Remember, this is equation 1. 150 minus T equals to 15A. And our T is 12A plus 120. So we just say 150 minus 12A plus 120 equals to 15A. We can open bracket here. 150 minus 12A minus 120 equals to 15A. This can go to the other side. Where 150 minus 120 equals to 15A plus 12A. So we have 30 equals to 27A. A equals to 30 over 27. A equals to, all right, let's we say this is 3 is 3 here is 10, 3 in 27 9. So A is 10 over 9 meter per second squared. Okay, so that is the acceleration. Okay, but we are not looking for acceleration, we are looking for tension. We're looking for tension. So we can say T equals to 12A plus 120, remember? All right, that will be 12 times 10 over 9. plus 120. T equals to 12. Now let's try to call 3 here 3, 3 here 4. All right, this will be 40 over 3 plus 120. If you simplify together, if you do this, we have T equals to, all right, LCM 40 plus what? 1 in 3, 3 times 120 is 360. So T is 400 over 3 Newton. That's that about that. Is that clear? All right, so we have gotten the what's it called? The tension in the string. So the question now, the next question says, let's go back to the next question. Find the time taken by the 15 kilogram mass to reach the floor. Find the time taken by the 15 kilogram mass to reach the floor. All right, so there we use the equations of motion. Okay, we use the equations of motion. All right, so we have for the 15 kilogram mass, what's the acceleration? Acceleration is 10 over 9 meters per second squared. All right, I remember that the question says the system is released from rest when the 15 kilogram mass is 32 meters above the floor. So that means to the floor, the distance covered must have been 32 meters. Are you with me? All right, and then released from rest means initial velocity is 0. So we're looking for T. So we have S, we have U, we have A. So we can use the formula S equals to UT plus half AT squared. Our S is 32. Our U is 0 times T plus half times, what's our A? 10 over 9. What's our T? We don't know. 2 here 1, 2 here 5. We have 32 equals to 5T over 9. This is gone. 0 times T is gone. So we have 5T equals to 9 times 32. So T equals to 9 times 32 over 5. Okay, so we have T equals to, what's 9 times 32? All right, sorry, this T squared, this T squared, sorry. All right, this T squared. Okay, now this is T squared, half AT squared. Okay, now if you look at it properly, you have T is 9 times 32. T squared, this T squared is 8, 18, 9 times 3, 27, 27 plus 1, 2, 8 over 5. Okay, so we have T, that's T squared. That will be T equals to square root of 288 over 5. So you can simplify that on your own. Is that clear? All right, so we are using S equals to UT plus half AT squared. Okay, okay.